All right, so David said the three states of matter are liquid, gas, and a solid. Why is this not going away? All right. So we got solid, liquid, and a gas. All right. So when we're talking about phase changes, okay, so really what we're talking about right now is physical changes. Specifically, we're talking about phase changes, okay? And then on Tuesday, we'll talk about chemical changes. But phase changes are physical changes. Okay. Phase changes are physical changes. And the reason why I have to say that is because when we start talking about chemical changes, you always make new stuff. So like a chemical change is like, I took this, I did something to it, and now I have new stuff. But sometimes people feel like with phase changes, you get new stuff, but you really aren't, okay? It's the same thing, it just looks different, okay? So we were talking about, there's 6 different phase changes, all right? And a phase change just means, okay, what happens when I go from a solid to a liquid, or a liquid to a solid, or a solid to a gas, or a gas to a solid, or a liquid to a gas, or gas to a liquid. That's all the phase changes are, okay? So even if you don't know the names of them, you know how to get to them. You either start with a solid and end with a liquid, or start with a liquid and end with a solid, that kind of thing, okay? All right, so when we were talking about phase changes the other day, okay? Ooh, very good point, Ryan. Yes, so phase changes are reversible. I mean, physical changes are reversible and chemical changes are not, okay? So once I take this piece of paper and I burn it, which is a chemical change, I cannot get this piece of paper back from the smoke and ashes and fire, okay? If I melt a piece of chocolate and it turns into a liquid, I can't get it to go back to a solid. Good point. All right, so let's talk about our phase changes. Brandon, if I were to put a bottle of water in the coldest part of my refrigerator, what will it do?
Get colder, freeze.
Yes, it will freeze. Very nice. So this is one of our phase changes. So freezing, all right, is one of our phase changes, all right? And freezing is going to take me from a liquid to a solid, okay? So I'm changing from a liquid to a solid, okay? All right, Julie, are you there? Julie, are you there? Can you hear me? Okay, fantastic. All right, Julie, if I have a candy bar, a Snicker bar, because that's my favorite, in my car in the middle of July, and I come back, what will have happened to that candy bar?
Melt.
It will melt, okay? So melting is another phase change, and this one is kind of the opposite of freezing, okay? So this one's gonna go from a solid to a liquid. Solid to a liquid. All right, very nice. What was I gonna do for my next one? Ah, I know, 1 second. All right, so if I just pulled this bottle of water out of the refrigerator, okay? And if I rub down the sides of it, my fingers are wet. What's that called? Anybody know what that's called?
Condensation.
Very nice, condensation, okay? So condensation, I know I had a liquid on my hand. Where do you think, anybody know where they think it came from? So it goes to a liquid, what's it coming from?
From a gas.
It is coming from a gas, very nice. All right, and that is condensation. Condensation. Very nice. Anybody know another example of condensation? When you wake up in the morning sometimes and you get ready to go outside, you walk across the grass, sometimes the grass is wet, which is weird, especially if it didn't rain. What is that called? What's the stuff on the grass called? Starts with a D, very small word.
You.
Dew, very nice. So dew on the grass is also an example of condensation, okay? What happens is there's always water in the air, right? That's really what humidity is. It's like how much moisture is in the air. So all that's happening is that water that's in the air, that is a gas, has now turned into a liquid on the grass, okay? And we're gonna talk about how that happens. All right, so did we talk about what going from a liquid to gas was called? Anybody remember what we said that one was? So liquid.
Evaporation.
Very nice, okay? Evaporation. Now, I'm gonna write this a couple of different ways, okay? So I just want you to recognize it regardless of how I write it. Technically, the term is vaporization. So if you have evaporation, don't erase it, okay? Just want you to write this one as well. There are two types of vaporization, okay? One is, I think that was David that said that. One is evaporation, which looks like vaporization, okay? And then the other one happens in your house, probably pretty often in the kitchen on a stove. Another
Boiling.
way, what is it?
Boiling.
Very nice, boiling, okay? So boiling is also a type of vaporization. Realistically, the only difference is where it's happening. Like one is happening on the surface of the water and one is happening underneath, okay? But if you see vaporization, evaporation, or boiling, those are all the same phase change going from a liquid to a gas, okay? All right, so then the last two that we haven't talked about, or that we talked about super quickly, I'm gonna show you some sample videos because they're kind of like the harder ones to conceptualize. Like we know what freezing and melting is, that's easy, okay? Condensation, we know what that is on the side of your
like the other one that changes from a solid to gas or something?
Yes, exactly. So solid to a gas, very nice. Solid to a gas, okay? And then that means we only have one other one left, and that's gonna go from a gas to a solid. All right, does anybody have written down, anybody remember the name from solid to a gas?
Sublimation? I forgot. I can't forget.
Exactly right. No, you're right, Janai. It's sublimation. Very nice. Sublimation. That looks rough. Hold on. Let me write that again. My little L and my I was rough right there. All right. Sublimation. Very nice. And then this one's called, looks like deposit, but it's deposition. Okay. All right. So let me show you a quick video on the two of those. Okay. One of them I think you're going to recognize. We'll see. Okay. And then the other one you probably haven't seen before. All right. So here we go. So this first one is here. Okay. All right, look at that. Look at the blocks of that stuff in there. Okay. Anybody know what that is? Oh, besides the fact that the title's up there.
Dry ice.
It is dry ice, okay? I just said it up there, I just forgot. All right, so it's dry ice. Does anybody know what dry ice really is?
Cold carbon dioxide.
Woohoo! David, gold star. Yes, it's carbon dioxide. And if you remember carbon dioxide, if we think back to, this is why I teach chemistry. Is that biology? Where does carbon dioxide come from?
Our bodies.
Our bodies. Yeah, that's true. So we breathe out carbon dioxide. Okay, that's like, I think plants need carbon dioxide, right? Don't they need it? Plants give off oxygen and we need
Yes.
oxygen. Is that right?
I think so.
Yeah.
You're the teacher.
Hey, I teach chemistry for a reason, okay? I am not a life science person. That's, yes, I think that's right. Oh, Janai said it's right. So yes, that's exactly what I meant. Haha. Yes, we give off carbon dioxide. We give off carbon dioxide because plants need it and plants give us oxygen. Haha. Yes, that's exactly what I was saying. So carbon dioxide is usually a gas, right? But if you get it super, I mean, super, super, super cold, okay, then you can turn it into a solid. Now, realistically, let me just put out here, this guy is being very unsafe. He's got this knife hacking at this carbon dioxide. He doesn't have on any gloves. Realistically, if you're dealing with dry ice, you should have gloves on because it's so cold that it could burn you, okay? So, and you also should not hack away at it with a butcher knife, just a thought. So let me just give that disclaimer. But as you can see, so he's kind of just chopping it into small pieces. He puts, he's just gonna fill this sink up with water. It's not like, notice it's not to the left or right, so it's not hot or cold water, it's just regular room temperature water. Now, before he even puts it in, what do you notice about the dry ice?
It's creating a gas.
Right, it's already changed to a gas. Now, at no point, if you look, I can go back a little bit, but that basket is not dripping, okay? There's no liquid coming off of it, okay? It's just smoking. It's going straight from a solid to a gas already. That's sublimation, okay? Now he puts it in the water and is making even more smoke or gas, okay? And let me tell you what's actually happening because it's kind of weird, okay? So if he walks on that, it'll be really cold, but there's no liquid there, okay? So real, yes, I'm gonna get in trouble. Okay, so realistically, dang it, David, now I forgot what I was saying. Oh, I know what I was saying. Okay, yes. So realistically, even though it doesn't seem like it to us, what's actually happening is that carbon dioxide as a solid is boiling, basically. It's almost like it's boiling, okay? So when we think of stuff as boiling, we think of it as being hot, but hot is very relative, right? I can be in this classroom and be like, oh my gosh, it is so cold in here. And Vincent could be like, it's burning up in here. Hot is very relative to whatever, okay? So for carbon dioxide, his boiling point is actually very, very, very low. He's used to being a gas. So for him to be that cold, for him to warm up, doesn't take a lot, okay? All right, so that's one. Now let me show you this other video. All right, this one is iodine, okay? All right, so iodine is really a solid, okay? They put some in a beaker, all right? And then this beaker, like right here, is sitting on a hot plate. So they're heating up this solid stuff. You don't see any liquid in there. It's not turning into a liquid. It's going directly to a gas. By the way, iodine is also dangerous. If we did this, we would do it in a fume hood, but I probably would not even do this in class because I would not run the risk. All right, so now they're closing off this beaker and trapping it with this flask. And this is filled with ice. Yes. You're gonna say something, Ryan? Or
Oh shoot, my thing's on. No, that's just my computer being mean to me.
that's okay. So now they're trapping the gas, okay? But here's what's gonna happen. Now they're gonna cool down this gas and it turns right back into a solid. Never at any point does it turn into a liquid. It goes from a solid, heats up, turns into a gas. And now you can see they cooled it back down. And now it is this nice solid. You got all these crystals at the bottom of this flask. They're just stuck on there, okay? So that's a close-up of the crystals, okay? All right, so that is, my dears, sublimation and deposition. Okay, so now let's talk about what is actually happening. Okay, what is actually happening? All right, so I'm gonna do a new slide. Is anybody still writing this stuff down right here? If you are, you can say something now or give me a thumbs up. Okay, so I'm gonna go to a new slide. So on this new slide, we're gonna still be doing solid, liquid, gas, but we are going to write it differently. Okay, I'm gonna do it kind of like a triangle. So I'm gonna do solid up here. All right, and you don't necessarily have to do it in the same order, but you got to keep up with if you didn't. So solid, liquid, and then gas. So it's kind of like a triangle. All right. We're not going to go super in depth as I could. We will later on in the year, but we're going to talk about what's happening when I go from a solid to a liquid, or a liquid to a gas, or a gas to a solid. Okay. But that also means we need to talk about it the other way. So we also need to talk about what happens as I go from a solid to a gas, and then from a gas to a liquid, and then from a liquid to a solid. All right, so get that drawn on your paper. We'll talk about what's happening. All right, so let's talk about, so we said if you're going from a solid, Vincent, if we go from either a solid to a liquid or liquid to solid, which one is which again? Tell me the name of one of them.
You said if we go from what?
Either solid to liquid or liquid to solid. You can tell me either one of them. Which one is which?
Melting.
For which one? Hold on, wait. Okay, Ryan, you give me the other one, but Vincent, give me one first.
All right.
So Vincent, you're either telling me what it's called when you go from a solid to a liquid, or what it's called when you go from a liquid to a solid.
Melting.
Melting for which way? Liquid to solid or solid to liquid?
Solid to liquid.
Solid to liquid is melting. Very nice. And then Ryan, you were going to tell me the other one, which is what?
You said melting, right?
Yeah, yes, you said melting.
So then the other one would be freezing.
Very nice. All right. So now realistically, all right, we're not going to go into super detail, but we're going to talk about what's really happening, because really it's the same thing kind of happening every time. It just depends which way it is. So if I have something and it melts, very general, I don't want you guys to think super sciencey. What is happening if something melts? Why did it melt?
It got warm.
It got warm. It had heat. Okay, so we're gonna say that for melting, you had to add heat. Okay. All right. So realistically, don't look at me like I'm crazy. Okay. Realistically, there is no such thing as cold. Okay. There's no such thing as cold, and we'll talk about. I wish you guys were here because I do a demo so you guys could see this. But there's no such thing as cold, really. There's only the absence of heat, which I know in your mind you're like, oh, duh, that's cold. But realistically, heat is the only thing that actually exists. Cold does not exist. It's just the absence of heat. So in terms of that, if melting is adding heat, what are we doing when we're freezing something?
Taking heat away.
Taking heat away. Very nice. So here we are losing heat. Okay. This is my don't tell anybody else. This is my good chem class. So I want you to take a few minutes. We're going to go through it too. We're going to go through it together. But I want you to see, can you look at the rest of the phase changes? So can you look at the rest of these, tell me what the name of this phase change is, what the name of this phase change is, this one and this one. And can you figure out which ones are you adding heat or are you subtracting heat? So take like maybe 3 or 4 minutes, okay? See if you can figure out the names of all the phase changes, which we've already done, okay? And see if you can figure out which ones do you have to add heat and which ones are you losing heat or taking heat away. Take about 3 minutes.